we gotta embrace technology, and so I'm gonna try to do integrals with Python. Anyway, yeah, I think it's great. I think it's a great excuse because in the uncertain systems roadmap thing, the exercise here, right? And I've been doing the, kind of reading the past, going through the past videos about like the whole Fourier transform stuff, and I think it's at an intuitive level. I understand enough that I'm comfortable using it, right? I understand why the integral makes sense. Maybe the inverse, it's not so clear, but let's just try to move a bit forward with the problem. And the problem is asking us to show the probability density of finding the particle with this momentum. And so, well, what means is, I guess, what we have to do is translate that to the momentum operator form, right? To the momentum form. So, and I don't want to take a look at the solution, but what I want to do is I wanna take a look at whether we can solve this with Senpai, for example. Let's see. And I think I started something with Replit, but I think I'll have to use the Replit. I think I did start something here where quantum mechanics exercises a month ago. Oh god. But yeah, so I think I was trying here something with I was testing how to solve this with Python, and then I realized that it's not that easy because, but I'm obviously a noob with all these, right? So the idea is just like to have like maybe a Python file. For some reason I couldn't get a notebook to work. You would prefer to use a notebook, but let's see, I don't know, Senpai seems to import like that. If I try to import it on a notebook, it tells me that it's not installed or that it's not available, so I don't know. I'll try to do some digging into this later on, but for now, this seems to, if I just hit run, this seems to work, or what? I think I just have to say Python x1.py. Do I? No? Or maybe this is the shell. Maybe the shell. What am I doing? So here, can you guys read that? Can I zoom in? Like, probably better like that. What if I just say Python x1.py? Does this work? Yeah, that prints B. Okay, so that actually at least works. I can just run the exercises like that and see what happens. And now I'd have to basically jump into this and say, well, let's try to do that. So what do we have? We have a free particle and a wave function that at t0 looks like that. And we know that alpha is a real parameter. And now the question is, compute the normalization factor. I mean, we could even try to do that, right? Because we know that at n, so we know that what this means is that if we do that, the integral of the probability density function has to add up to 1, and maybe that's a way for us to solve for n. So what we need to do is have the wave function kind of, do it like these, then calculate the, so kind of do the times the complex conjugate, and to get the probability density function, and then which I kind of forgot why was that intuitively obvious. We'll probably have to explore that again, but and then kind of like do the integral of that, and then assume that integral has to equal 1 and then solve for n. So let's maybe try to start with these, because to be fair, I have played with Senpai in the past, but not so much. And so if I just like, let's take Senpai quantum mechanics. First of all, let's see what is in there in terms of quantum mechanics, because I know there's something, right? But I don't really know how much of it I can use. Constants, dagger, inner product, tensor product. These are kits. It's too specific. So I just, it's too. What is that? Operators. So you can define operators. No, let's just use, so. Well, what I would do is, and this is like exercise 1.2, is it? Is it one? Is it? It's two. Oh God. Rename. Cool. And so we import Senpai, and maybe first thing we want to do is n equals set expression, or no, symbol, sorry. Is it symbols? Is it a symbol? Do I have auto-completion in here? Hello? 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 Auto-completion? Do we have that? How do I do this? No, format source code, no. I don't have a. Why is that CPU so high? Settings, debugger, packages. Oh, there's a packages thing here, NumPy, Senpai. Okay, whatever. I just had it here before, right? Is it symbols? Okay, basically. So this is n, which is what we're looking for. And then we've got like alpha, which is basically, or we'll just call it, we'll just use a, because alpha is too long to write. And then R. What is R though? Because here it's not involved. So R, I'm just assuming is the radius, right? So we'll just define it like that. And then basically what we have is the wave function, right? It's basically a how do you write expressions in Senpai? Just Senpai. I think you just do it, right? Yeah. So you just actually write the thing. So you just actually just say, for example, n times. Is it exponential like that? I think so. Minus a times r, and then print. Like, how does these? So shell cool, yeah, nice. But I wanted to is it so invalid? invalid syntax. Senpai. Yeah, it's exp. Okay. Yeah. Okay, so print. How can I print stuff nicely? Oh, print like that. In any case, this will happen in the IPython Qt console. LaTeX. Init printing. What is init printing? Let's try that. I don't know actually why I have to. Do I have to run it? To be honest, I don't know. Does it print it nicely? Yeah, okay, but we don't have LaTeX installed, I guess. Init session, that's interesting. Init session. There's an interactive way to work. Interactive Senpai sessions. That'll be cool because simplification. What about I try to run these in the shell. Can't I just copy that? Oh, here's a shell, but I wanna. Can't I just copy that? Oh crap, I have to start Python, obviously. Python, and now paste. So this is like that. Oh, what? Init session. I like that. That's actually okay. Aha, so you kind of have all these things in here. You have a bunch of things available for you. Ah, interesting. What if I just okay. So what if I just run these commands? No. Ah, okay, because I have all the SMP and stuff like that. No. Okay, cool. So let me. So what if I just say n equals symbols n, a equals symbols a, r equals symbols r, and then I'll just say n times exp of minus a times r. Ugh. Yeah, okay, that actually tries to print it in a nice way, but it's not really. Okay, interesting. Yeah, but maybe it's too complicated for this to be interactive, right? Because I have to define all these different things before. Yeah, but maybe that works, as in like I don't really have to kind of keep like defining all the stuff. But yeah, that there's an advantage to doing it like this. Yeah, it's fine, I guess. How to actually? Yeah, okay, cool. But it's cool to know there's an interactive mode. So I have this stuff here, and now what do I want to do? So what I want to do is I want to find the complex conjugate. So Senpai yeah, the thing is I want to use I'd like to be able to use the what is these? Oh, it's April's Fool's joke. I didn't realize. Oh god. Interesting. Filters for stack overflow and just for selfies anymore. I think I'm not into the mood for this right now. Solve. I want a complex conjugate. How do I do that? Sign apps arc conjugate. Okay, so it's just there's just a conjugate thing, right? Functions, but like, are these things available to me? Symbols. Oh, I have to import all this stuff. Import conjugate and okay, so yeah, but I think actually I'm pretty tired of writing all this stuff like this. So I think I'll just say from Senpai import all. I know that's not the best practice, but what can I do? Does this still work? Yeah, that still works. Cool. But I don't get autocomplete, so I want to get autocomplete like these, or what? Anyway, so what if I just say conjugate is just the conjugate? Well, I can say alpha is real, so I can just actually say type. Oh, look, actually I can symbols. I can type true. Integer true. Just say real true. Okay. Real true, right? So we know that alpha is real, because that might make it easier for these. And so yeah, okay. Conjugate of n, and then okay, but here you can see, because it knows it's real, it knows the conjugate is the same, so it actually, but yeah, okay, so that kind of is the expression. And so now what if I just say times wf, right? Do I have to actually rerun the thing every time, or can I just, no, okay, I don't have to click hit run. Okay, so that's these, and now I want to integrate, right? So Senpai integrate, integrals. How does this work? Integrate, just integrate. It's fairly straightforward. That's pretty cool. So I'll just call it I'll just say, okay, so what if we just want to do with the integrate? It's like an indefinite integral, right? So we want to integrate that. Integrate. Dummy variables. What dummy variables? Okay, so indefinite integral, definite integral. Okay. Why is it telling me that I need to do that? I don't know. Specify dummy variables for. So Senpai dummy variables for. Oh, so I need to know, yeah, okay, what the variable is. Of course. What is it that we're integrating? We're integrating over R, I guess. Right? I guess we're integrating over R. Takes a while, so it's doing something. Which is great because I don't have to do it by hand. Yay! Okay. Times the integral of that. That's nice. Okay. And now, so now I know. So and I was like, this must be equal to 1, and I have to solve for n. How do I do that? So. I guess solve. So I guess solves always for 0, right? Solve. So what does solve do? Okay, we suppose all equations are equal to 0. So solving these, it translates to solving these. Solve for x. So what happens if I just say solve these minus 1, right? And we solve for n, and we print. So we integrate, we solve for n, and we print, and that can probably take quite a long time. And what is the solve gonna tell us is what n is. I can just say n. Can I just say that? And then say print end. It's pretty cool though. Yeah? Let's see. If that works, then boom. No, okay. So okay. So I can't just say solve like that, I guess. Can I just say, so can I just run it like this, see what happens? Do it again. Okay, so what do we have here? Invalid limits given. Oh, sorry, what is that comma here? Whoa, exactly. So you integrate these on R, you minus it 1, and you do that. Yeah. See what happens. Oh, come on. There you go. No? This. Solve. There you go. Integrate yeah. Sorry guys. Now this one is taking a while. And we'll see if that actually leads into anything. I mean, we can start taking a look at the solution maybe in the meantime. A, so okay. Pi. So A is like, boom, that's the solution. Let's see if that's, God. Okay, let's see if that's what happens. And I didn't print it. Awesome. So let's just print this thing. It didn't take forever. It didn't break, so that's not a bad sign. Yeah, whatever I get, I think I'll leave it here. I'm happy I just managed to. I think that's good. It's a good way to do that. Basically, try to find a way to speed up these exercises so that it's not always about, like, you know, the identities and all that stuff. Like, I'm happy if I have a way to solve programmatically the equations and stuff like that, and at the same time I try to understand what they mean, right? Whoa. Yeah, sure, but how do I evaluate that? That's the thing, right? Like, how do I even know minus square root of the integral and stuff like that? Like, I'm gonna simplify that. Simplification. Simplify. So let's see, simplify, and we have another parenthesis at the end. See if that does anything to it, and we'll leave it here, I guess. Why is there, because these are two possible solutions. Okay. And here's just like something that simple. It depends on alpha, but not on R. Okay, simple. Huh? How though? How is it possible that it? I mean, R is just R. Because that really gets you. That really forces you to think, right? In terms of the symbols, not symbols. What is really a symbol? What is not? Like, because I wonder how you would do this by hand. And why am I getting a attribute? At least object has no attribute. Replace. Simplify needs a measure. Simplify A. Simplify doesn't really need a. Maybe it just doesn't let me integrate. Solve. Yeah. let's see, what is this trying to tell me? Let's try to take on like paint. It would be cool if Replit would have like something to take to draw like that. Yeah. So I mean, actually I have it here. So it says minus minus, why doesn't it work? Okay, so it says square root of 1. Oh god, what's gone? Why? What's going on here with this pen, man? Why isn't this working? I just wanna... Oh god, that doesn't work. Anyway, oh. So 1 over the integral of e to the power of minus ar times e to the power of minus a. Ah, okay, so r is, I think that's what makes it like r, the r conjugate. I think, what if I tell that r is real as well, right? Is it gonna make it easier? What is it gonna tell me? Because I think that's what's blocking the thing from solving. What is that? Piecewise. Square root of 2 times square root of... What is piecewise? Kopieren, piecewise. What is piecewise? So these are different solutions, I get. And it's still times square root of minus a. Why isn't these, sorry, the conjugate of that? It's a real, right? It says a radius. We know alpha is real. We know n can be anything. So I think that is correct. That we conjugate it, and then we say the probability. So these times these, unless this is not, yeah, no, this times these minus 1 and solve for n. I think this should be correct, but I'm getting something weird, and I have to find a way to, you know, make sure I get the type of result that I want. I'm just not sure I understand that. So piecewise, I guess this gives me all the different solutions, right? Copy, So essentially, that's one. That's another one. Okay, that's another one. This is all. So these are the solutions. Non-true. Why non-true? I don't understand that. But anyway. Okay, so I guess it's telling me such time equals 0. But this is far from any of the stuff that you can see here, right? So here it's like they say n equals like a, so alpha. Okay, I mean you can think of these as a like a root, right? Because it's 3 divided by 2. So it's the square root of these to the power of 3 in a way. So okay, that's not maybe not bad that there's square roots in here, but it's definitely not this, because the square root of 2, there's no 2 anywhere. What is it? Yeah. Because if I would do this by hand, it would be like, as I said, right? So so we have that form, and then we have like you know, N, E, and then alpha R. The conjugate is just the same, so I would just say that, you know, so the square thing here would be just N, E, how do you do that? So do you, I think it's like that, right? So times 2, and then you do the integral of these, and basically the integral of these is just I mean, we know this is a constant, like times constant. So a times exp of something like this, right? And I want the results in English, and or do I have to do whatever per parts? I think I might have to do this per parts. Yeah. I don't have any examples here that I can steal from. Yeah, but it's essentially, it's like, So essentially it's like the constant times the integral of that minus the integral of these times when it's like this is 0, right? So the constant can just go out. I think that's correct. It's correct to assume that. So n squared goes out, and then you have the integral of e to the power of minus which is basically the same as just e to r2. So n so basically if these must be equal to 1, well then we know that, you know, cosine, so this is basically, yeah, I guess so, cosine of like minus r2 plus I sine, no, that is not true. That is not true. That is only true when there's a complex exponent, correct? Correct. And these are all real things. So what we know is that the square root of these is and times that. So we know it's like n squared times these must equal 1, right? And so n is 1 divided by this stuff, which is the same as like actually just making the exponent positive and having a square root of 2, and now this just makes no sense. This thing here just makes no sense. Why there's an alpha to the cube? Oh, fine. Maybe I'm just fine normalization constant. Maybe that's just I mean, I think I'm following the right procedure, but hey, who knows? Seems like that's what we're doing there, equaling it to 1. So okay guys, I don't know why, unless I have to add the time evolution to it or something. But I don't know why that is the case and why it's pi and whatnot. Solution A. Anyway, good progress though, at least with the Replit stuff as well. So got that to work a little bit. Cool. Yep, see you next time.